Imagine you're in an alpine meadow at about 3,500 meters in the Himalayas. You're surrounded by mountains. Five species of bush warblers that are potentially singing around you. Each one has a call that's completely different from the other, although they are so closely related to each other. There are Himalayan tar, which are this really ancient creature that's still living in the Himalayas, and they have these males with long horns and saddlebacks and really shaggy coats. As soon as I think 8 or 9 hits, this heavy bank of mist generally rolls in and completely blocks out all of this view from you. So you see this magical thing only between 6 and 8 in the morning when everything is clear and it's crisp and it's beautiful. Um, I mean, that place is one of my favorite places in the world, definitely. I'm Sahas Barve, and I'm a second year PhD student in the Ecology and Evolutionary Biology department at Cornell University. My research at Cornell basically focuses on elevational distribution of birds in the Himalayas. I'm interested in finding out what drives where the birds live in the mountains. That's sort of my ulterior motive in doing a PhD is so that I get to hang out in the field a bunch and observe birds and yeah. So I grew up in Bombay, and so Bombay is this huge city with 18 million people. But fortunately, Bombay also has a big national park within it, and it's probably the only megapolis in the world which has a big cat that lives within the city. I would go out and on trails in the national park and walk around, initially hoping to see the leopard, but increasingly I got interested in other things. I got interested in the cicadas and the frogs and the flowers and the birds. During the first year of high school, I attended this camp run by the Bombay Natural History Society and met real ecologists who were doing real ecological work at that point. That was really important and really impactful, I think, in my life because they showed me that these things can still be done, and there's so much that we still need to know about the natural world. During the 2 years that I took off between my master's and my PhD, I studied the movement of rhinos and water buffaloes across this corridor. I studied king cobras in a rainforest where we were tracking radio tagged king cobras. Uh, I helped this PhD student finding a field site for her in central India where she was going to study tigers and their impact on the depredation tigers have on livestock in those areas. So I tried to basically diversify as much as possible, but somehow I couldn't cut myself off from birds. In any of the big mountain ranges that you see, be it the Andes or in the mountains of Africa or in the Himalayas or even in Papua New Guinea, you see elevational stratification of species. So species will uh, are distributed only in narrow elevational bands along the elevation gradient. Although this pattern is really common and widespread, we really don't know why this happens or how this comes about. The most widely tested hypothesis is interspecific competition, which means that each species is driven by competition from the species below and species above. I'm also interested in how physiology affects the distribution because as the elevation increases, the partial pressure of oxygen goes down. And so by the time you've hit 3,500 meters or 3,600 meters, the amount of oxygen in the air is only about 60% of that at sea level. But if species don't have the capacity to adapt to these high altitudes because of their physiology, how much ever the temperature increases, it's not going to help because the oxygen content of the air is always going to stay the same. So I'm interested in whether competition, in addition to or in association with lowering amount of oxygen in the air, drives the elevation range of a species. So I'm looking at the adaptations to hypoxia by measuring various parameters in the blood when I misnet for birds. And I'm sort of quantifying interspecific competition by doing song playbacks and doing studies of nest boxes. There are basically four things that I do in field. Number one is misnetting. So we catch birds, and I take very detailed measurements, morphological measurements of each bird that I catch, and I band each bird to give it a number so I can track if I catch it again and stuff like that. The second thing I do is study the adaptations to hypoxia, or the partial pressure of oxygen. For that, I'm looking at measurements in the blood for about 14 species from different families. I take a small blood sample, and in the field, I quantify the hemoglobin concentration of the bird's blood. The third thing that I'm doing is sound recording. I go out in the mornings, again before dawn, and record bird song. So I record those songs, and then I sort of use those as in what are called song playback experiments, where I play these songs back to other males. I'm seeing if they A, recognize the song, and B, if they recognize it, if they respond to it at all. The fourth and the last thing that I do is to study how tits compete for cavities, and they do it in two ways. In the winters, they fight for cavities as roosting sites, and in the summer, they do it as for nesting sites. I'm interested in whether the same bird occupies the same nest box throughout the season, or if other birds are coming and occupying. Generally, most fieldwork ends up being a really large Excel data sheet, and so basically this is a record of all the birds that I caught this summer, and it has the band number and all the morphological data that I collected. Now for next few months, while I'm here at Cornell, what I'm basically going to do is sift through this data and try to find patterns. So it's basically going to be playing with this data set in different ways to try and answer the questions that I'm interested in. I think talking about birds is much more engaging for people who don't know about wildlife, and so they're a really good mode of communicating your science. Education really helps people, primarily because I think they don't know about nature and about their own backyard and all the really cool things that are there in their backyard. And if we want to conserve remote, far off places, we need to start with places that people can relate to. And I think that was my motivation in doing all these things. So I think me being here in Cornell, having been born in Bombay, I think shows you that basically anyone can study birds and can become an ecologist. And as long as you have the passion and love that I think I have for the outdoors and especially for birds.